Hi everyone. In the given problem statement of two sum, input array is sorted. In this given problem statement, we are going to have an array of number in unsorted order, and we have to find the two indices or the two number addition of which is going to give us the target value. So for example, let us take this array which is in sorted order 2, 7, 11 and 15. And our target value is 9. And it has been written that there is exactly one solution that is always going to be present. So we can have two pointers. So pointer I could be 0 and j could be n minus 1. So now a question might arise whether 2 plus 15, the value is 17. 17 is greater than 9. So in that case, what we need to do, we need to decrement our j pointer. So we are going to decrement j minus equal to 1. So our current j pointer would be at 11. So 11 plus 2 is 13. 13 is again greater than 9. So we are going to decrement j pointer and our j pointer would be at 7. Now 2 plus 7 is 9. 9 equal to 9, which is true, and we are going to get the indices of 1 and 2. That would be our output, and we are going to return 1 and 2. Similarly, in the example of, let us take some other example. 2, 3, 6, 7, 10. Okay, and our value would be 9 in this case. Initially both of them at the 0th and n minus 1 position. So 2 plus 10 is 12. 12 is greater than 9. So we are going to decrement the value. Let us take it as 8 for the time being. Okay, so now we are going to at 8 position. So 2 plus 8 is 10. 10 is greater than 9. So we are decrementing it back to this position. Now 2 plus 6 is 8. 8 is smaller than 9. So in that case, right, we are going to increment our ith pointer. Okay, so in case the value is greater than the target value, then we are going to decrementing our j pointer, and in case the value is smaller than our target value, then we are going to increment the ith pointer. So this is a very important thing to remember. Okay, now 3 plus 6 is 9. So 9 equal to 9, which is true, and we got our output. So our output would be the index 1 and index 2. So this would be our output, and we can return it. Here one thing to note also, that instead of 0th index generally which we follow in Python, here the indexing is like 1, 2, 3, 4, not from 0, it is starting from 1. So that is something we have to take care of. So by having two pointers which would be at 0th position and the j could be at n minus 1 position, we can easily solve this problem with a complexity of big O of n and even lesser than that. So now let us jump quickly to the Python solution. Now let us create two variables which are two pointers I and j. So the value of I would be initialized as 0 and j would be length of numbers minus 1. Now we are going to loop it through while I is less than j. And we are going to have a temporary variable which is going to store the sum of I plus the sum of jth index that is present in the number. As we have told, if our temp value is less than our target, in that case we are going to increment I plus equal to 1. If our temp value is greater than our target, then we are going to increment the ith pointer by plus equal to 1, and in case our temp value is exactly equal to our target, then we are just going to return the indices of I and j. So else return I plus 1 and j plus 1. The reason being that this is following the way the output is required. Generally in Python we have an indexing of 0, but here the way they are expecting the input, or the way they are expecting the output, that indexing is starting from 1. So that's why we are just making a small change. We are just giving a value plus 1 out here. Let me run the code. It should run the public test cases properly. It is saying it is out of range. Okay, I made a mistake. So we are going to decrement the j pointer. Okay. And let me submit the code. As you could see, our code got submitted. And if you look into the time complexity of it, it is big O of n, which is pretty efficient. I think you can increase it. As you could see, our runtime also got increased to 81.57%, which is pretty efficient. Our memory is also fine. So in this way, we can easily solve the 2-pointer problem.